Similar to practice number 1, practice number 2 I'm going to ask you to do on your own as well. It says determine whether the table represents an arithmetic or geometric sequence. Then write a recursive and explicit function to represent the sequence. So I'd like you to try that on your own first. So go ahead and pause the video, and after you've attempted all 4, then I want you to unpause the video. You can take a look at my work and the correct answers to see how you did. Now that you've had the opportunity to try this on your own, I want you to take a look at my work, and I'm going to go through the answers with you. Starting with letter A. In letter A, I've written it out, noticing that I've multiplied by 2 each time, and I always want to compare kind of the x term with the number of 2's. Since I'm multiplying by 2 each time, repetitive multiplication indicates that I have a geometric sequence. So I'm going to start by filling that out. This is geometric. Then I need my recursive equation. So my recursive equation, since I'm using f of x, I have f of x equal to my previous term, f of x minus 1, and I'm multiplying by 2 each time. And then I also have to list that first term. In this case, the first term is f of 0 equals 3. And then my explicit equation, for my explicit equation, I have f of x equal to, I'm starting with 3, I'm multiplying by 2, and this is where it's really important to take a look at my x compared to my number of 2's. They are exactly the same number. So my exponent here, the number of 2's that I am multiplying by, are the same as x. Then we can move on to question letter B. First thing you should notice is that you are multiplying by 3 each time. That multiplication by 3 each time tells us that we do have a geometric sequence. So if I do my recursive formula, this time I have g of n and n. So my recursive equation is going to be g of n is equal to g of n minus 1. And then I'm multiplying that by 3. And then for my recursive, I also need to list that first term. G of 1 is equal to 2. Notice that in my letter A and my letter B, this one started with 0, so my first term was f of 0. This one started with 1, so my first term was g of 1. This can change depending on what the first number in your table is. Now, for my explicit function, I have g of n equal to, I started with 2, I multiplied by 3, and then let's compare the number of 3's to my n values. So the number of 3's that I need are 1 less than my number of n's. So my exponent should represent that I'm multiplying by 3 n minus 1 times. Then we'll move to letter C. So in letter C, first thing that I recognize is that I'm adding 2 each time. So that adding 2 each time tells me that I do have an arithmetic sequence. My recursive equation, this time I'm using d of t and t. So my recursive equation will be d of t equals d of t minus 1 plus 2. And then I do need to list that first term. So in this case it's 0. So d of 0 is equal to 7. Then I need to do the explicit equation. I lost that line on the video. You should have it in your notes to fill out. But that explicit formula, so let's write this explicit, is d of t equals, I started with 7, and this time instead of multiplying in those geometric sequences, I'm adding the same number each time. I'm adding 2, and then I need to check how many times. So I'm adding 2, the exact same number as t, so this would be 2 times t. And then finally, let's take a look at letter D. In letter D, I notice that I'm adding 4 each time. So adding each time is going to tell me that I have an arithmetic sequence. And then my recursive equation, since I'm using P of R and R, would be P of R equal to P of R minus 1, that previous term, plus 4. And then I also have to list that first term, and here this time it's P of 1, which is equal to 9. And then I need that explicit equation. That explicit equation, I have P of R. I started with 9. I'm adding 4 each time. And then let's take a look at our number of 4s here. The number of 4s is 1 less than my R term. So this is 4 times R minus 1.